Okay, so this is the example 2, a second example of learning objective 1.4, connecting the number of particles to moles and mass of substances. And in this example, it is quantitative and qualitatively expressed. So we have our question here. We have a sample of sucrose, and they gave us the formula, which is C12H22O11. They told us the molar mass of this sucrose is 342 grams per mole. And the question is, they want to know how many carbon atoms are in a sample of 684 grams of sucrose. So a couple of different ways that you can set it up, but one way is you can recognize that they just said that 1 mole of sucrose weighed 342 grams, and that ratio of mass to moles is always going to be set for this sample. So if 1 mole weighs 342 grams, then X number of moles will weigh 684 grams, which if you do your cross multiplication and division, you come up that it is a 2 mole sample. Okay? You can also set that up with dimensional analysis, in which case, I'll do that real quick, where we have a 684 gram sample that they give us, and we are told that 1 mole of the sample weighs 342 grams. My grams cancel, and I'm left with the knowledge that I have a 2 mole sample. So we have 2 moles of sucrose of our C12H22O11. Okay? Now, we need to go between moles of this sucrose and atoms of the carbon. So if I draw a model of my sucrose, this is not the molecular structure of sucrose, and it doesn't have to be. All we're doing is making a picture so that we can sort of get our head around what this molecule looks like. And so this has C12H22, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons in this molecule. I'm going to have 22 hydrogens, and I'm going to have 11 oxygens. So I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 oxygens, and then my 22 hydrogens. So here's 11 of them. There's 11 hydrogens. Then I've got 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now, this is not the structure of it, but I've just drawn it out. AP Chemistry, the test, they love pictures. They love to give you a picture of something and have you come up with what does this picture mean. So all we did is draw a picture. And so now if I have this picture drawn, if I have one of these molecules, one of these big honking molecules, so 1 C12H22O11, how many carbons are in there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 carbon atoms. All right, so it's the same as our little subscript. All right, so if I have 1 mole of this, that would mean I would have 12 moles of my carbons, because this ratio is the same all the time. So I have 2 moles of my sucrose. So if I write it in dimensional analysis form, I have 12 moles of carbons for every 1 mole of C12H22O11, which means I just have to multiply by 2, and it gives me 24 moles of carbons. All right, so for practice, I know example 1, I put the same one up. In your textbook, which is the Brown, LeMay, Bernstein, page 49 through 51 is a read. Page 68, you have 3 problems here, 33, 37, 39. Also, here's a help video on this topic. It's bit.ly/2IA9DZD. And if that doesn't work, change that to a lowercase l, but I think it's an